Okay, so we're going to look at a couple more examples of these indeterminate forms, because remember on the exam there's going to be one similar to the examples I've done here on this video. So let's look at another one here. So this is the limit as x goes to infinity of x to the 1 over x power. Now of course we want to make sure this is an indeterminate form. I mean, obviously it's going to be that on the exam, but we want to know what form this is. So this is going to go to infinity. And then 1 over x, that's going to go to 0. So my form is infinity to the 0 power, which again is one of the indeterminate forms. Now just like the previous example that we did in the previous video, you can't say, oh, infinity to the 0 is 1. Because remember, first off, infinity is not a number, and these are limits. We're not talking about evaluating a single number. We're looking at limits. It's approaching infinity, and this is approaching 0, but they never actually reach either of these things. All right, so then let's look back at the original problem here. So we've got the limit as x goes to infinity of x to the 1 over x. And remember, I like to do this as y equals. Then you say the natural log of y is equal to the limit as x goes to infinity of the natural log of x to the 1 over x power. Now on this one, sometimes people get a little like, oh my gosh, this isn't going to work kind of thing, but let's see what happens, because we're going to write natural log of y is equal to the limit as x goes to infinity. We bring the exponent down, 1 over x times the natural log of x. Now, before you start trying to say, oh, I got to move something into the denominator, let's just think about this for a second. I've got 1 over x times the natural log of x. Well, 1 over x, and this would be natural log of x over 1. So if I actually simplify this out, just as it's written, I'd have natural log of y is equal to the limit as x goes to infinity of the natural log of x over x. And if we check this here, this goes to infinity, and x of course goes to infinity, so I'm in the form infinity over infinity. So whenever you see a 1 over x exponent and you bring it down in front, you're actually already going to kind of be able to set yourself up in this infinity over infinity or 0 over 0 case. Alright, so then let's look at what we got going here. So I have natural log of y is equal to the limit as x goes to infinity of the natural log of x over x. So now we can apply L'Hopital's rule. So you get natural log of y is equal to the limit as x goes to infinity of 1 over x divided by 1. Because derivative natural log, of course, is 1 over x, derivative of x is 1. So simplifying this out, we get the natural log of y is equal to limit as x goes to infinity of 1 over x. But wait a minute, that limit is just 0. So we got 0 there, but we have to be careful again, just like in the previous example, is we need to make sure to write the actual final answer down. And so remember, what you have to do is this would be y is equal to then e to the 0 power, which is 1. So again, let's write what we just determined here, that the limit as x goes to infinity of x to the 1 over x is equal to 1. Now you might say, well, hey, whoops, sorry about that. You might go back and say, well, wait a minute. You said that infinity to 0 is not necessarily 1, but it turned out that it was 1 in this case. That's just because in this problem it turned out to be 1. But I could make a variation on the exam that would not cause this to be 1 anymore. I could, well actually, yeah, I could, but I won't go into that. Alright, so let's look at another one here. Let's look, it's going to look very similar to the previous problem. Limit as x approaches 0 from the right hand side, and that's because we want to deal just with positive numbers in this case. X to the x power. And you can kind of see why I want to deal with just positive numbers, because negative numbers, especially if you're dealing like with square roots and stuff, you know, we get complex numbers out. All right, so we're going to approach this the same way we've been approaching all of them. So this is the limit. Well, first off, we should check the form here. Well, the form's pretty easy. X is going to go to 0, and the exponent's also going to go to 0. So it's in the form 0 over 0. So then we have the natural log of y is equal to the limit as x approaches infinity of the natural log of x to the x power. And just like we've done on all of these examples, natural log of y is equal to the limit as x goes to infinity of x times the natural log of x. Now, this one does require us to manipulate this. This form here not 0. This form is actually, wait a minute, infinity times infinity, if I think about it. Yeah, I guess this one is infinity times infinity. Let me just make sure I haven't made something silly here. Ah, I know what that is. I did do something silly. You probably all caught it already. It's not going to infinity, it's going to 0 plus. So let me... The reason infinity times infinity was confusing me is that that's not an undetermined form. If two things are going to infinity and they're multiplying, you're just going to infinity. So this is actually 0 plus, 0 plus. I'm going to pause the video for a second because my email keeps buzzing and you're probably hearing that. Okay, I turned my email off, so hopefully you don't see it. So let's get back now that I've fixed the limits here. Let's determine the form here. So x is clearly going to 0. Oops, I'm in black there. I like to write these in red. So x is going to 0. But then let's think about it. I'm going to put it off to the side here. Natural log of x. What happens to the natural log of x as you get close to 0 from the right-hand side? Well, let's just even graph what the natural log looks like. You should know what these graphs look like because they can help you determine limits. We know it's got an intercept of 1 and goes off to infinity slowly, but then it goes down like this. That's what the natural log function looks like. So what do we have here then? Well, we have that this is form 0, and now it's technically negative infinity, but remember when we talked about it, it doesn't really matter if it's positive or negative infinity, it's 0 times some infinity. Alright, so that means I need to rewrite the form, and we know with these problems we always leave the natural log in the numerator. So this is going to be the limit as x approaches 0 from the right hand side of, sorry, my pen just, of natural log of x over x to the negative 1. And now this is in the form infinity over infinity. So we can apply L'Hopital's rule. And natural log of x, of course, the derivative of that is 1 over x over negative 1 x to the negative 2. Okay, so then let's see what happens when we do that. Here, we can't forget the negative here, so we're going to have to simplify this out a little bit. Is equal to the limit as x goes to 0 plus of 1 over x divided by negative 1 over x squared. So you get the natural log of y is equal to the limit as x approaches 0 from the right-hand side. And if we simplify this out, we would get negative x. Which, of course, evaluating that, we just get 0. So again, just like in the previous example, we wound up getting y is equal to e to the 0, which is 1. So the limit as x approaches 0 from the right-hand side of x to the x power is equal to 1. Alright, there's two more example problems I'm going to do, but I'm going to actually make a separate video for those.